Okay, so we start at 3.3 today, and we are going to be performing the same arithmetic operations on both sides of an equation to create an equation that is easier to solve. So we are going to be looking at solving a little bit more complicated problems, so multi-step problems, whereas we've been just solving one-step equations. And we're also going to be looking at equivalent equations, so determine if two equations are equivalent or not. So similar to what we've done with trying to determine if two expressions are equivalent. So we've been using tables to determine the solution to an equation. So what we're going to do, we're going to look for an easier and sometimes more accurate way of solving an equation, because we know plugging in those numbers over and over for the table, that can be tedious, and sometimes we're in between two numbers, so it's not as exact as we need it to be. So when solving equations, which we've been working with, make sure that we always keep the scale, which I'm referring to as the equation, balanced. So whatever we do to the left side, we must also do to the right side. Or if we do something to the right side, we must also do something to the left side. So remember, keep that scale balanced. That equal sign is kind of the middle of the scale, so where everything is referenced from. So whatever we do to the left, we must do to the right. Keep that equation balanced. I cannot stress that enough. When solving an equation, no matter what, every single step from the original equation to the end, the left side must equal the right side. Every single step has to be equivalent to the original equation. So left side must always still equal the right side. We are just rearranging or manipulating the equation to look in a different way to allow us to solve the equation. So what are equivalent equations? Equivalent equations are equations that have the exact same solution. So we know two equations are equivalent when we plug in a value and we get the same outcome, the same output. So let's look at an example. Are all three of the equations below equivalent? Explain why or why not. So if you think back to when determining whether two expressions were equivalent, we wanted to see, did we get the same thing when we simplified everything out? Or we also took numbers, multiple x values, and plugged them into the expression, and we checked, did we get the same output with this expression as we did with this expression? And then we checked it several times to determine whether or not they were always going to be equivalent. Well, now what we're saying, hey, x equals 3. So that means the solution, the value that should make all of these equations true, would be 3. If it doesn't, then these are not equivalent equations. So what we do, we go through and check. We're saying x equals 3, so let's take x and plug it in there and see, does the left side equal 11? Then let's plug it in here and see, does the left side equal 6? So 2 times 3 plus 5, does that equal 11? 2 times 3 is 6, plus 5, 11 equals 11. So it's a solution to this equation, meaning x is a solution. That's the value of x that makes the equation true. So then let's try it for 2x equals 6. So does 2 times 3 equal 6? Well, yes it does. So that also checks out. So these equations are equivalent because they have the exact same solution. So when x is 3, we get the same outcome every single time. The left side always equals the right side. So no matter what, 2 times something plus 5 is 11, that something is 3. 2 times something is 6, that something is 3. So every single step, that value of x made each equation true, each equation was balanced, left side always equaled the right side. So they are equivalent because they have the same solution. In this case, that solution was 3. So let's look at actually solving some of these. So we want to make sure that we show each step. We are solving the equation. We want to get to the variable all by itself, and then we will check our solution to make sure that we are correct in our with our solution. So first thing, what are we trying to get by itself? What is that variable we want all alone? Y. So I want to start to move everything away from y that I can. So the very first thing that I can do, I have negative 6 times y plus 72 equals negative 114. So I can go ahead and move this 72. I want to make this 0. So I'm adding 72, so what do I do to both sides? I subtract 72 from both sides. 72 minus 72 is 0. I'm still left with negative 6y equals negative 114 minus 72, negative 186. So I've gone from a 2-step problem now to a 1-step problem. So this is what we have been used to seeing. So what do we do at this point? We have negative 6y, which what does that represent? Multiplication, equals negative 186. So how do I get y by itself? How do I make this just a 1y? Well, any number divided by itself is always 1. So I get y equals, we know a negative divided by a negative is always positive. And what do we get? Pick up your calculators. We should get 31. So what's the value? What's the solution? What makes this equation true is when y is 31. So we want to check that solution. So we take our answer, we take the original equation, and we want to see the value of y, does that equal, does that make the equation true? So I plug it in. So I'll tell you what, you go ahead and finish that. The question is this a solution? So you tell me whether or not this is right by finishing this. Make sure left side equals right side. Okay, let's look at another one. Negative 41 plus 5 times something must equal 99. So before we would take a table and we say, okay, what if x is 5? What if x is 10? What if x is 3? What if x is negative 1? And see, okay, which one's going to give me, what value of x would give me 99? So now we are solving these algebraically where we're trying to isolate that variable. So the variable is x. So I first want to move the negative 41. It is not directly attached to x, so it's the easiest thing, one way to think of it, is the easiest thing to get rid of first. I can kind of just push it away. So I have negative 41 plus 5x. How do I make this 0? Negative 41 plus 41 is 0. If I do it on the left side, I have to do it on the right side. So that's 0. I'm left with 5 times x equals 140. So now what do I do to both sides? Now I have that equation that we're used to seeing, 5x equals 140. 5 times x equals 140. So I want to figure out what value of x multiplied by 5 gives me 140. I want this just to be a 1x, any number divided by itself. So I take 5 and I divide it by 5. So 5 divided by 5 is just x, or 1x. And then what is 140 divided by 5? We get 28. So now what you're going to do, you're going to come over here off to the side and you are going to check the work. So get used to doing this because you will know whether or not you are correct before you ever turn in any work. So again, you're checking to make sure that this is a solution, which means my left side equals the right side. So go ahead and finish up that check for tomorrow. C, you're going to do on your own. So make sure you do C for tomorrow, and then let's look at this very last one. I'll get you started. My variable's in, I want to get it all by itself. So what's kind of barely hanging on there? That minus 1, you're subtracting 1. So how can I move it or get rid of it first? I have minus 1, so I can say, okay, what's going to make this 0? Negative 1 plus 1. So I have 3/5 n equals 30. So 3/5 times n equals 30. So you may be thinking, well, okay, that's multiplication, so maybe I'm going to divide both sides by 3/5. But remember, when we multiply any number by its reciprocal, we always get 1. And the goal is to get this to just be a 1n. So what could I multiply 3/5 by to make it a 1? Or what's the reciprocal of 3/5? Remember, reciprocal, you just flip the fraction. So it is 5/3. So multiplying by the reciprocal is the exact same thing as dividing by that number. So dividing by 3/5 is the same thing as multiplying by 5/3. So 5 times 3 is 15 over 3 times 5 is just 15. So we end up with 15 over 15n. Well, we know 15 divided by 15 is just 1. So again, any number multiplied by its reciprocal is always 1. So that just becomes 1. Then multiplying fractions, this is the same thing as 30 over 1. So 30 times 5 is 150 divided by 1 times 3. So n equals, and I'll let you get it from there. And the last thing you'll have to do for this one as well is your check. So we come back here and we want to check the work to make sure that we did it correctly. So whatever value you get for n, you will plug it in. All right, finish this up for tomorrow, and then we will work with some more problems and maybe some more harder problems tomorrow as well.